Today we'll cover section 11.2 on compound interest. Recall that in discussing simple interest in the previous section, we defined some terms like interest, principal or present value, and future value. Now in the discussion of compound interest, which is today's topic, the future value is also sometimes called the compound amount. So principal and present value are interchangeable terminology, and in the context of what we'll talk about today, which is compound interest, future value and compound amount are equivalent terms. Remember, we talked about simple interest last time, and just as a way of summarizing it, simple interest doesn't pay interest on the interest earned. Compound interest, unlike simple interest, the interest is factored in. In other words, interest paid is added to the initial deposit and the interest begins to earn interest. Or similarly, if you're talking about a loan, the interest owed is added back into the total amount owed and begins to incur an interest charge of its own. So that contrasts with simple interest, where the interest itself never collects interest. So compound interest, the interest itself either receives interest if you're saving money. For compound interest, this is kind of an extreme example. I did an example with 50% interest rate for simple interest, but let me take that same example, and it is extreme. Nobody's going to give you a 50% interest rate, but it illustrates the point. We have a simple interest with 50%. I did that last time. I want to take that same $100 principal, same 50% interest, but this time I'm going to let it compound at 50%. Compound interest versus simple interest. You can see what happens. In the first year, if you put in $100 and left it for a year, at 50% interest, you would earn $50 at the end of the first year. At the end of the second year, you'd earn another $50, and at the end of the third year, that $100 would earn yet another $50. So far, it's just like simple interest, but here's where it differs. The interest that you earned in the first year, in this case $50, in the second year earns its own 50% interest, which means it earns $25. And then in the third year, it earns another $25. And then if you move to the second year, that $25 that you earned in interest also earns interest for the third year, and 50% of 25 is $12.50, so that $25 would earn $12.50 interest. So you can see every amount of interest starts earning its own interest, and that's what compound interest is. And that graph gives you what's called the interest trajectory. Most interest-bearing accounts pay compound interest rather than simple interest. There are cases where simple interest comes into play. In terms of common consumer transactions, you will almost always be dealing with compound interest, where the interest itself earns interest or charges you interest if you're talking about a loan. To calculate the amount of interest earned in a compound interest account, we have to know how many times during the year that the interest is paid back and added to the account. That quantity is called the compounding period. Here are the common compounding periods. If you compound once a year, that's called annual compound interest. If you compound twice a year, that's called semi-annual. If you compound 4 times a year, that's called quarterly. Monthly is 12 times a year, weekly is 52 times a year, and assuming you're using the ordinary method, daily is 360 times a year. Remember in the last discussion we talked about using the ordinary method most of the time when we talk about daily interest rate. I won't derive the formula for compound interest, but I will give it to you. This is it. The formula for the accumulated value, or sometimes we call that the future value, of compound interest is given by the formula capital A is equal to capital P times the quantity, which is the sum of 1 plus R divided by N raised to the power of NT. That capital A is called the future value, or as I said earlier, sometimes it's called the compound amount, and sometimes I call it the accumulated value to sort of make sense of the capital A. So if you hear future value or compound amount, we're talking about the capital A. Capital P is the principal or present value, just like it was with simple interest. Little r is the annual interest rate or APR, just as it was with simple interest. Little n is the number of compounding periods per year. This only comes into play for compound interest. There is no compounding with simple interest, so this is a new variable. And little t is the time in years, just as it was for simple interest. So basically, we only have one new variable, and that's little n, which is the number of compounding periods per year. We have one new variable, and we have the new formula. For example, $2,000 is deposited in an account paying 4% annual interest compounded quarterly. How much money will be in the account after 3 years? Using the formula, principal is the amount you started with. You put in $2,000, so the principal is $2,000. The annual interest rate is 4%. That's 0.04 as a decimal. It's compounded quarterly, which means 4 times a year, so n is equal to 4. And you notice I'm just plugging these numbers in, and we're doing it for 3 years, so for t, you plug in 3. Now it's an arithmetic problem. There are any number of ways to do this with your calculator. I'm going to try a standard way and sort of stick to it. When I do these problems like this, I tend to go ahead and multiply the exponent there. So in this case, I would go ahead and multiply the 4 times 3 and get 12. Once you get to that point, it's very easy just to enter the whole thing into your calculator, and I'll show you how. It involves the parentheses key. You've got the left and right parens that sit about midway of your calculator buttons. How do you use it? Well, I would suggest that you actually write out what you're going to type in before you even start to minimize the mistakes, and I think I can explain to you why that might be helpful. If you look at this problem, these are the keystrokes, and if you write them out before you even start typing them in, you're less likely to make mistakes. So for instance, the first thing I'm going to do is enter 2,000. That's the principal. Now if you look at the formula, there's no multiplication symbol. There's an implied multiplication. When you put a number next to parentheses in our normal writing of things, that's an implied multiplication. If you go ahead and write down times before you start typing it in, you're less likely to forget to press the multiplication key. If you don't press that multiplication key, you're not going to get the right answer. So even though there's no multiplication symbol in the original formula, when you write a number next to a left paren, that's implied multiplication. So it might be a good idea to actually write that out. And then you see the left paren, so you press the left paren button on your calculator, then you type in 1, then you type in plus, then you type in 0.04, then you hit the division key, then you type in 4, then you type the right paren. Now here's another place you might forget if you're not careful. That 12 is an exponent, so you have to press the exponentiation key on your calculator, or the power key, and that is the X to the Y button. And if you look on your calculator, it's one of those buttons above the red clear and all clear buttons in your calculator. Press that power key. That tells the calculator that you're about to type in an exponent. Once you press the power key, now you can enter 12. And then to make the evaluation of the expression complete, you press equal. And if you do all of those things, you will end up with $2,253.65006. And if you round that off to the nearest cents, that will be 65 cents. So it would be $2,253.65 rounded to the nearest cent. If you put $2,000 in an account paying 4% annual interest compounded quarterly, at the end of 3 years, you will have $2,253.65 in that account. Final step in all these problems is to think about, does that answer seem reasonable? You start out with 2,000. 3 years later, you've got about 2,250. Nothing flashes in my mind as being obviously wrong with that, so I think that's probably okay. If you get something like $20,000, you know that something's wrong with that, and you can go back and find your mistake. Let's try another. How much interest is earned in 9 years on $8,300 deposited in an account paying 8% interest compounded semi-annually? And then we'll round the answer off to 2 decimal places. Be careful here, though, because what you're being asked for is the interest earned and not the future value. The formula that I just gave you to calculate for compound interest is for A. A is the future value, and we only want the interest. But remember, the future value is just the total amount in the account. So if you want the interest, you can still use the formula for capital A, but before you give your final answer, you just have to subtract off the principal, and that'll leave you with just the interest earned. So don't get so involved in doing the calculation that you forget that the question actually only asks for the interest. So you start off with the same formula. The principal is $8,300. The interest rate is 8%, which is 0.08. It's compounded semi-annually. That's twice a year, so N is 2. And it's for 9 years, so T is 9. Plug into the formula, and if you use my technique, you'll go ahead and do 2 times 9 and get 18, and then go to your calculator. I can type that entire expression in my calculator now in one swoop. I'll type in the 8,300. That's an implied multiplication, so I have to hit multiplication. Then I do left paren, then I type in a 1, then I type in a plus, then I type in 0.08, followed by the division symbol, followed by 2. Hit the right paren to close the parentheses. The 18 is in the power, so I have to hit the X to the Y, which is the power key. That tells the calculator that I'm about to type in a power. Now I can type in 18, and when I press equal to, the display should show $16,814.28 rounded to the nearest cent. And again, the last step is to see if it's reasonable. You start off with 8,300 and you end up with 16,000 something. That seems a little high until you think about the fact that you left it in there for 9 years and you were getting an 8% rate, which is pretty good. So I can see that happening and I don't question it. Now, if you got 160,000, you'd say that's definitely a red flag and I probably did something wrong. Always think about that when you finish a calculation. And again, we weren't asked for A. A is the amount in the account. The problem asked for the interest. So all you got to do is figure that you took $8,300 and turned it into $16,814.28. So the amount of interest you earned is actually the difference between those two numbers. So had they asked for the amount in the account or the future value, the answer would have been $16,814.28. But because they only asked for the interest earned, you have to subtract off the principal. So the answer would be $8,514.28. Some problems might actually ask us to solve for capital P, the present value, instead of capital A, which is the future value. For those problems, it might be easier to solve the above formula for P and use it instead. So if you take that formula that we learned at the beginning of the section, capital A is equal to P times that quantity raised to a power. If you're actually solving for capital P, you could just plug the numbers in directly into that formula and solve for P later. But one thing you could do is divide both sides by that expression raised to a power and solve for P directly. And then plug in numbers. So for example, if I told you that the capital A was 15,000, that the interest rate was 7% compounded monthly, and we were leaving the money in the bank for 5 years, you could calculate the present value, which is the capital P, by using that bottom formula. You could also calculate it using the top formula. The bottom formula is already solved for P. Is the only advantage to using that formula over the top formula. They're the same formula written in two different ways. One is solved for A, one is solved for P. But if you use the bottom formula, you're going to plug in 15,000 for A, 0.07 for R, 12 for N, and T is equal to 5. And if you take my advice and multiply the 12 times the 5 together to get 60, at this stage you really can take that entire thing and type it into the calculator all at once. And there are your keystrokes. You type in 15,000, the fraction bar is a division symbol, then you hit the left paren and do 1 plus, then you type in 0.07, and then the slash is another division, so you hit divided by 12, then you want to close the right paren. That 60 is in the exponent position, so you have to press the power button, the X to the Y. Then you type in 60, and if you press equal to, it will do the entire calculation, and before rounding, you get a present value of $10,581.07557, and if you round that to the nearest cent, you get a present value of $10,581.08. And again, that seems reasonable that if you took about $10,500 and left it in the bank for 5 years at a pretty decent interest rate, you could end up with $15,000. So it doesn't seem unreasonable, so I will accept that answer. I have no reason to question it. Let's try another. How much money should be invested in an account that earns 3% interest compounded monthly in order to have $11,000 in 5 years? And then round your answer to 2 decimal places. Again, since we're looking for the present value, it probably makes sense to use the version of the formula that's already solved for capital P. But as I said before, you can still use the top formula. It just requires a division at the end if you do it that way. But I'll use the second formula. $11,000 is the future value. In other words, you want to have $11,000 in 5 years later. That $11,000 is a future value. That's what capital A is. The interest is 3%, which is 0.03. It's compounded monthly, so N is 12, and you're doing it for 5 years, so T is equal to 5. Again, if you go ahead and take care of the exponent, do 12 times 5 is 60, you can type the rest of it in. 11,000, the big fraction bar is a division, then you've got a left paren, 1 plus 0.03, and the slash is another division, divided by 12. Then you close the right paren, then you hit the power key because the 60 is an exponent, then you type in 60, and you hit equal to, and you end up with a present value of $9,469.560164, and if you round it to 2 decimal places, you end up with $9,469.56 to the nearest cent. And again, it seems fairly reasonable that you start off with a little less than $9,500, and 5 years later you end up with $11,000. That doesn't seem to raise any red flags in my mind, so I'll accept that answer.